All right, welcome back. So previously we looked at this theorem, which again is we're going to be using now. It has really three results: uh, one for a sum, one for multiplying by a power, and one for composition. So we're going to use that now in conjunction with the one series we absolutely know what it converges to, and that is our geometric series. Okay, that's our geometric series or power series that results from the geometric series. Right? Because we know that that will converge as long as that power, that ratio is less than 1, and it'll converge to 1 over 1 minus r, which now we're replacing r with x, be 1 over 1 minus x. Okay, so let's look at that now, and let's use that now to write down a series. Okay, let's use that now to write down a series for some different functions here. Okay, so let's say we want to write a power series for each, and we also want to know when they converge. So we'll write a power series for each. So let's say we want to write the function x squared over 1 minus x. Well, we know that 1 over 1 minus x is the series x to the k. So we can think of this as x squared times 1 over 1 minus x, right? And the 1 over 1 minus x we can write as an infinite series. So this would be x squared times the sum as k goes from 0 to infinity of x to the k. What's that going to look like? Well, if k is 0, that would be x to the 0 times x squared. That would be x squared. Next term, k equals 1 to be x to the first times x squared, be x cubed. K equals 2, that would be x to the fourth, and so on and so on. So we see here all we're doing is just taking the k value and we're adding a 2 onto it. So this would be the series. Sum as k goes from 0 to infinity of x to the k plus 2. So that series is going to converge to that series. It's going to converge to that series. Okay? And it's going to converge to it as long as the absolute value of x is less than 1, or actually absolute value of x squared, I should say, has to be less than 1, right? X squared has to be less than 1. So that would be true as long as absolute value of x is also less than 1. Right? X squared would be less than 1 when this is true. So this is going to converge. So this is defined. This is equality is equal. X squared over 1 minus x is equal to x sum at series k goes from 0 to infinity of x to the k plus 2. X to k plus 2. And that'll converge as long as x is less than 1. Absolute value of x is less than 1. I want to show you a little neat feature here with our Desmos graphing device. We can actually define a series, sort of, because Desmos does offer the ability to do sums. So first, on the one hand, let's just look at the function here. 1 over 1 minus x. All right, so there it is, 1 over 1 minus x. But we want to go ahead and limit it now just to x between 1 and minus 1. Okay, so we're going to make a limitation on it here. So we're only looking at the graph there for x is between minus 1 and 1. Those are the only values that we look at. Okay, so those are the only ones that matter. So let's look at the series now. Y equals, I have it down here, sum Now they forced me to use the variable n, so I'm going to have to use n. So n equals 0. Now I can't do infinity, so I'm going to do like, just started out doing like 10. And this is just, again, x to the nth power. Now, of course, that's what it looks like right now as we go to 10. Right? It's producing values and so on. Okay, let me slowly increment this and make that, say, 100. And now let's take a look at it. You see, it's starting to agree a little more with the red graph. Right? It's starting to lie alongside. Now, again, this is only, right? This is only going to converge ultimately between -1 and 1. But you can see that the agreement, at least, between -1 and 1 is pretty darn good. It's laying almost directly on top. And again, as we do more and more, then that will also be the case. It takes a little bit longer because it's got to compute the first 1,000 terms. But you see, we have this other piece over here that's not in agreement. And if we go on here beyond 1 on the graph, I don't know what's going to happen. If the graph will even show anything beyond 1 or not, but it's certainly showing stuff over here at around -1 where it should just be stopping. But you can see kind of how it is converging there, at least between -1 and 1. Okay, so that's just kind of a little visual confirmation of the result we found. And we could again look at the new function, x squared over x squared over 1 minus x. So just throw him out there. There's x squared over 1 minus x, and now I'd have to go in here to get this to lay on top. I'd have to take and make that +2. Now, +2 on the exponent. I don't know why it's. I have to do it this way. Okay, so you can see now if I go to that series, again, for those values, the blue graph is laying across it. Okay, so that's just, again, kind of a little visual confirmation of the result that we have here. Okay, this series is laying in line. And again, it's only working as long as x squared is less than 1, which would happen when absolute value of x is less than 1. Okay.